Hello, so in this video we are going to explore how to completing the square so that we can solve the quadratic function. So when it comes to quadratic function, you will see in the form of ax squared plus bs plus c equals to 0. So a we call it is the quadratic term. Quadratic terms and should be ax. Bx is the linear term. C is the constant term. So why do we need to completing a square to solve the equation? That is because if we see equation look like x plus 5 squared equals to 18, by what we learned earlier before, we know that if we take square root on both sides, we have x plus 5 equals to positive and negative 18. And then we simplify, we have positive and negative 3 times square root of 2. And then we minus 5 on both sides. Then we can solve for x without factoring, and then move that function and set the function equal to 0. So I have a negative 5, positive and plus or minus 3 times square root of 2. So look, if we can write the function in terms of something parentheses square equal to some number, then we will be able to solve the equation. So that's the idea why we need to completing the square. So here is the trick. If you have a problem such as, let me start with an easier ones. X squared plus ax equals to 4. But this is not a square, so what do we do? Now, the whole process is you need to identify the coefficient of the quadratic term and the coefficient of the linear term. So the coefficient of quadratic term a is equal to 1. The coefficient of linear term is b equals to 8. That's all we need to know. So what you're going to do is you want to add 1/2 b squares on both sides. That's what we're going to do. So I have x squared plus ax equals to 4. Now I am adding, our b is equal to 8, right? Because that's our linear term. Half of b squared Now I will end up to write this equation as x plus half of b equals to 4 at 4 squared, which is 16. So basically the idea is we will have a plus bx, x squared plus bs plus half of b squared. We can write it as x plus b over 2 squared. So that's why we need to add half of b squared so that I can write it into x plus b over 2 squared. Okay, so in here, let me simplify a little bit. So I have x plus 4 squared equals 20, and then I can take square root on both sides. So I have x plus 4 equals to, when you're taking the square root, since this is a odd root property, so I need to have a positive and a negative number. So I have positive and negative 2 square root of 5. Now I can subtract 4 on both sides. So our solution is going to be negative 4 plus or minus 2 times square root of 5. All right. What if we have some number that the coefficient is not starting with a 1? So it's very important that the quadratic term, which is our a, is equal to 1. If it's not, you want to set that equals to 1. So here is some examples. I have 3x squared plus 18x minus 6 equals to 0. We don't care about the constant term. So since we don't care about that, I can move that to the other side of the equation. So I got 3x squared plus 18x equals to 6. Now, our a is equal to 3. B is equal to 18. But that's not going to work because we want our a equals to 1. So how do we do that? Well, we can divide by 3 on both sides so that I can set the quadratic term a equals to 1. Now, I got x squared plus 6x equals to 2. So the next step is I'm going to add b over 2 squared on both sides. In our case, our b is equal to 6 over 2 squared on both sides. So that means I'm adding x squared plus 6x equals to 2 at 6 over 2 squared. Now, the square is already formed because the square is going to equal to x plus b half square. Now, this function will become x plus 3 squared equals to 2 plus 9. Simplify, I have x plus 3 squared equals to 11. Solving it. Remember that when you're solving it, you need to take the even root property. So I will have positive and negative solution. So x plus 3 equals to positive and negative square root of 11. So x is equal to negative 3 plus or minus square root of 11. Okay, what if you will make some fractional number, which is fine. We use the same thing. We just need to divide by half or multiply by 1/2. So here is an example. If I have x squared plus 5/3 of x equals to, let's say, 1. So what do you do? So our a already equals to 1. Good. So we don't need to do everything about it. Now, our b is equal to 5/3. In order to complete the square, you want to add half b squared on both sides. So 1/2 times b, our b is 5/3 squared. So that gives us 5/6 squared. Now let's do that. 5/6 squared on both sides. So our equation becomes x squared plus 5/3 x at that. Okay. So on the left side of the equation, we will end up to have x plus 1/2 b and then square. In that case, we have x plus 5/6 square. All right. So x plus 5/6 square equals to 1 plus 25th over 36. Now simplify. I have x plus 5/6 square equals to 36 over 36, because we can write a 1 into 36 over 36 because I want to find the common denominator. Simplify, I have 61 over 36. Now take the square root on both sides. If you're taking the square root, remember that you need to have a positive and negative. When I'm doing that, I have x plus 5/6 equals to positive or negative square root of 61 over 6. Because square root of 13/6 is equal to 6. And then you will subtract 5/6 on both sides. Okay, so your solution is going to be x equals to positive or negative square root of 61 minus 5 over 6. Okay, so you don't need to worry about fraction, or when you see fraction you're so scared. We just follow the same step. We multiply 1/2 b squared and then add it on both sides. Okay, so here is an examples. I have 2x squared plus 20x plus 48 equals to 0. Well, you can separate the constant term from the variables. So that means I want to move 48 to the right side of the equation. So I have a 2x squared plus 20x equals to negative 48. And then, like I say, our a is equal to 2. And we don't want that. We want a is equal to 1. In that case, you need to divide it by 2 on both sides. So I have x squared plus 10x equals to negative 24. Now, we have b. b is equal to 10. So that means we want to add half b squared on both sides. Half b squared on both sides, which is 5 squared on both sides, because our b is equal to 10. So the equation gives us is x squared plus 10x plus 5 squared equals to negative 24 at 5 squared. So after I did that, your complete square should equal to half b squared, x plus half b, and then parentheses square. So I got x plus 5 squared equals to 1. And then using the even root property, I have x plus 5 equals to positive and negative 1, square root of negative 1, but square root of 1 is equal to 1. So that means x plus 5 equals to 1, or x plus 5 equals to negative 1. So solution should be x equals to 4, negative 4. Or x equals to negative 6. That would be the solution. Okay, so it's very important to, let me recap this, is you want to add to complete the square. You want to add half b squared on both sides, and then your equation will become x plus b over half squared. But in order to do that, you want to measure the a, the coefficient is equal to 1. So you want to divide it by 1 on both sides. No, divide it whatever the coefficient they have, so that I can set a equals to 1. So here would be a good example for us to practice. So I have 3x squared equals to 2x minus 7. First step is you want to separate the constant term from the variables. Now, in order to do that, you want to move 2x to the left side of the equation. I have 3x minus 2x equals to negative 7. So the next step is, I know that a is not equal to 1, right? So in order to set a equals to 1, you want to divide it by 3 on both sides. So I have x squared minus 2/3 of x equals to negative 7 over 3. Now, we have a equals to 1. We have our linear term b equals to negative 2/3. So half of b is equal to 1/2 times negative 2/3, which is negative 1/3. So the next step should be you want to add 1/2 b squared on both sides. Then my equation, I got x squared minus 2/3 of x, adding negative 1/3 squared equals to negative 7 over 3, adding negative 1/3 squared. So when you're adding this, make sure that you are adding half b squared on both sides, not just one side. Now, the square we're forming is x minus 1/3 squared equals to 1/9, negative 3 over 1/9. Okay, now we can simplify it. Let me put a note here in case we forget. We want to complete that as x plus half b squared. Okay, so find the common denominator 9 and then do some calculation. We will end up to have times 3, so I have a negative 20 over 9. Now use the square root even root property. So I have square root them on both sides. Now I have x plus 1/3 equals to positive or negative 3 over square root of negative 20. So how do we simplify square root of negative 20? Square root of negative 20, I can write it as negative 1 times 4 times 5. Why do I want to say it in that way? Because square root of negative 1 equals to I, square root of 2 equals to 2, and square root of 5 is we can't factor it anymore. So that means square root of negative 20, I can write it as 2 times square root of 5 times I over 3. And then you can subtract 1/3 on both sides. So your equation is going to be that. And then you organize a little bit since they already have a common denominator. So you will get positive or negative 2 times square root of 5i minus 1 over 3. So that's it for how to use complete square to solve the radicals.